Hey guys, welcome back to the channel. I have this time working on a Toyota Camry 2003 2.4 liters. Customer concern is, let me just read. This comes from United Mechanics shop here in Virginia, Fredericksburg, Virginia. ECU problem, technicians complain. Hook the scanner to car diagnostics. A scanner does not communicate with the ECU but communicates with all other modules. Notice security light was flashing while cranking. Reset the immobilizer module with no change. Check engine light does not illuminate. With key on, suspect ECU to be faulty as all fuses and relays are good and functioning. Okay, let me just cover some of the customer information so I can show you what I have here. So these are my main connections to the computer. So I always have to do the homework, especially with, again, not a common vehicle that I work every day with. But so we got powers on. I will show you in the computer. This has connectors E6, E7, E8, E9, and E10. Most of the connections, as you will see here, are in the connector E6. Powers are the ones I need. Ignition on pin 9, battery on pin 1, and like I name it as a terminal 87. This is more like a European style thing, but I'm very common or used to those. So ignition is terminal 15, terminal 87 is key on constant power or power, not a ignition. And then the terminal 30 is a constant power, like a like a wake up or not a wake up, sorry, a keep alive memory for the computer. And this is in terminal 3. The grounds that I need for this are in terminal connector E8, terminal 1, and connector E10, pin 28. The rest are for sensor grounds and other functions of the computers that I'm not checking now. Communication, we only need for this scanner or the scanner to communicate with the computer. Again, in connector E6, pins 11 goes to DLC 7, and pin 14 goes to DLC 13. I'm also checking the 5-volt reference on pins 26 and 27, and then sensor grounds on pin 28 and 29. I'm also, again, doing a test on the to see the response on the computer on the coolant temperature on pin connector E10, pin 19. So I have marked, and it's actually very nice. In Identifix, you can find the correct pinouts on the computer. This is the computer, not the harness on the vehicle. A little, let's say, different when you're working with Japanese vehicles. They refer as ground as E's, and then the main grounds are always going to be E1, 2, 3, 4, whatever they name, as many as main grounds they want to put. And then sensor grounds or anything else will be named as E01, E02, 3, 4, and so on, right? So as you can see here, battery power, they're saying for testing this, you will be in connector E6, terminal 3, and then in connector E8, terminal 1. So battery and then E1 as a ground. And it should read in between 9 and 14, depends on the battery of charging condition of the car, right? So, but yeah, E1 as a ground and the E63 as a power ignition switch. So they do name most of their things correctly. You can go. Sorry, I was saying if you look into this into Identifix, which this is where I got this information from, look for like connector E6. You can go, let me actually go there so I can show you how you can find that. As you can see, I have a lot of stuff open, but yeah, so when you're in the wire diagrams, it will tell you what the terminal or the connector number is. So let's say, this E6, there is no hyperlink in here, but if I go here in home and I type just E6, it will give you recommendations based on that. So I scroll down and I go over to pinouts, right? So I always hit the show all on the right side to make sure I got all the information that I need in case, right? Let me just see where I was. One sec. Let me just find out. SCI terminals. Okay, this might be the one. SFI system terminals of ECMs because that's simplified fuel injection system. So, yep, that's the one. So you see, it's a little bit different when you're working with Japanese information, but they're very good. So when you find this information, it tells you the correct pinouts and where to check. So let me scroll down to, you see what it says now, E01, E01, and connector E10-7. And then if I go over to the wire diagrams, which obviously we will have two here, you can see I got that information right there. Remove the bookmark because I already selected it. But if I go also to the wire diagram, let me just make sure I am in the correct one. So again, select all. Engine immobilizer, no. Yeah, I think that this is where we can select this. You can also make sure that when you're doing an analysis on a wire diagram for Japanese vehicles, let me turn that reflection away. Read little information because they're very good on colors, they're very good on connectors. Everything is, I really like the Japanese wire diagrams because they're actually really, really accurate, especially Toyota. So let me just zoom a little bit on this, but yeah, make sure that you see this. You see they are naming the connector E6 as A, E7 as B, E8 as C, and so on. So A, B, C, D, E. So again, and then start to name it. I don't ask me why. I mean, the reason they do that is because the E6 will be too big to have it in here. So they just rather have an A, you see, with the connector in here, because what they do in this wire, they're going to make a round symbol and they put the name, the number and the letter in there. So this is pin 1 of connector E6, which is A, right? So now we know that that is there. So and then you can go down and check every single of the harness because um, I had that pin out from Protoman at first and I wasn't trusting too much information. I like to check every single pin before I do this because again, you have to understand when you're in the vehicle, you don't have to do much of a check as far as that because all you can just do is, let's say if it is six connector one, two, and three are green, yellow, and then black. Now you know which one is six. But since I don't have the connector on the vehicle, I have to be very careful because is this is six and that is a 10, you know, you can flip the computer and then I can cook a computer. So that's why I have to be very, very careful of what I do. And this is how I check. So yes, I can go down and find every signal that I put in here. So if we go over to, let's find E1019. I want to check that one. So E10, we will be looking for connector E or in the symbols as E, and we'll be looking for pin 10. Sorry, pin 19. So let's look for E on this circle 19. And let's scroll down. No E19 in here. No E19. I'm going really fast. I'm very good with like letters and numbers from my brain as far as when I'm looking for something. Hopefully I'm good this time. Oh, I couldn't find it. How is that possible? Was I in the first page? Because that's very important. You know, when you're doing your check, um, to be on the first page, and you will see because you know when the computer, when you see on the Japanese diagrams, when you have this kind of like a, I don't know, like a wavy line, that means it's incomplete. So let's scroll up to where it's closed, like here. You see, this is a close. That's why we missed it because it wasn't a page before. You see, this is a close. That means ends right there, right here, E19. So E19, what it says in here? Engine coolant temperature sensor. So that That's how I found this information. I like to use as much as possible original um, diagrams. I do compare it to the colored diagrams to make sure that sometimes it's actually errors in here. I have not seen many on Toyota, honestly, I mean, to be honest, I have seen more those in European like BMW, Mercedes. Mercedes, not so much. Mercedes is a little more confusing because there's so many different applications that uses the same um, computer and the same sensors that is sometimes a little overwhelming. But when you work more and more in those, you get better with. Japanese diagrams, on the other hand, are very specific. The only thing that might change and it tells you is the automatic and manual transmission, or if it's two different transmissions they use, they tell you, and they will tell you here, transmission EU15 or transmission whatever number it is, and that will apply to the manual that you're looking for. All right, so this is what I do or what I did. I had the computer on. I have, as you can see now on E1019, the coolant temperature sensor signal. I have an E6 5-volt reference and sensor ground, which just turned off because of time, but 5-volt reference is good. I can then change that to, because I'm now checking, if I look into that, um, pin, that is the second pin on the bottom. So if we go over to the connector, which I have open in here, the second one will be 27. So we can move it over to the first one, which is the other 5-volt reference. And this is the nice about these terminals that I use that are very, this is like factory connectors. So that, and they're insulated. So I am not worried about shorting anything. But how is that other 5-volt reference? It's perfect. So I can show you that I was on the second pin and I am now on the first pin. I cannot fit it all the way in, but it's perfect. Same thing with the ground. We can see here that we got grounds on 28 and 29. I am connected now on pin 28, so we can see that the next pin, hopefully, let me move this light a little more this way. You can see that that pin and that ground is not connected. So it's on the first one. I'm going to move it over to the second one, and again, second pin on the first pin, right? So we got the yellow on the first pin and the black one on the fourth pin, 5 volts. So how is that 5 volts on this computer? Perfect. So the next test that I wanted to see, well, is the computer able to communicate with a scanner? Well, sorry guys, phone call, but yeah, so we have a temperature, but that doesn't mean it can be empty. But so what I did is I connected a ground in through the gate box resistors, and I can change to anything, and then that to terminal connector 10, terminal 19, right? So that's the coolant temperature sensor, and I'm going to change the values. You see how I'm going now to 219? I can go higher on the resistance, and that's going to drop the temperature. And we can see that it's responding. Actually, I went too far, right? Because I went to 0. But yeah, I can actually add more. You see, right now I'm in 62 degrees, 50 degrees. So the computer is responding perfectly. I don't have the entire vehicle in order to perform an automatic ID. So I had to manually enter the bin, that is the bin on the vehicle. Like, let me click out of here and then restart that so you guys will be able to see what I did. We like to end the diagnostics, yes. So we're going to get completely out. I got updates to do, and I'm going to show you that automatic ID will not work. Now can I cover this paper because I'm going to need to read that bin to select it, and most likely it saves it. Again, for this one, I'm using the Phoenix Max from Top Down. This is my go-to tool here. and it works perfectly. So yes, we can see that we can read the bin, but I can now select it from the bins that I have entered previously. We have 774989, so 774989, and then just click OK. That is going to tell me that it's a 2003 Toyota Camry, as it says, and it's not electrical vehicle, so no, just a Camry. And then after that, I click Quick Access. In this, I will just select 16 pin because I'm going through the communication, let's say, of um, DLC. I can actually, with what I am doing or how I am doing it, I can select either one. So let's try that. I did enter this way. So let's use this 17 pin Toyota and see what it does. So let's enter the ECM. Let's see if we can read data stream. No, this 1992, so that's not for this. So we have to go back. Oops, too much. Let me see this one, ECM, because that will tell me year and read data stream. Again, that's not, this says 1992. I guess that's for a very old vehicle. Set area, North America. Okay, 16 pin now. We can do that. Are you sure you want to exit? No. Also, all you need to do is select the area and go into 16 pin DLC. This is still not talking to the computer, but I will try to read the bin. If the ECM has the bin, it will read it. This is not a Kentucky. Let me just see. Tennessee. So it's not taking him because those are informations I don't have. This will be right where the bin number is. So let's use yes the order. We click OK. That is just a warning in case you have connections or something connected to the OBD port. And this is where I am. So you can go into um, the ECM. And one thing that I want also to show here, when you're using the top down, you can go into system list. This is going to tell you exactly where you are. So you can enter the OBD2 generic or the engine computer original. You can do ADAS calibration if the car has a service function, customer setting, and vehicle information. So you see if I can see the vehicle information back in there. I can enter OBD2, again generic. This function is used for OBD2. So let's see if we can connect this way, which we should. Remember, this is only for emissions, so I should probably just talk to the computer. And this is also a way to communicate. Mail status is on, and this is something that I have to also um, save or check. So I will probably uh, pause the video for a second and connect the test light to see if the check engine light comes on or no. Yeah, data stream supported. It says that yes. So let's enter. Let's read um, live data. We only have the engine coolant temperature sensor, so we might be able to see battery voltage, but maybe not in here. But let's do the test the same thing. So we have 50 degrees. That's exactly where we left this before. So let me change that temperature. And as you can see right now, we're in 120, 125. You see, how is that? It's working and it's reading 100%. So I have just proved two different ways that this computer has perfect communication, and things that made me immediately um, curious was because this computer is 100% clean. There is um, no water intrusion, no corrosion, so nothing to go by like that. Let's try to read fault code. The problem is with nothing connected. They have not supplied me with any fault code, so not even sure what would I be reading in here. The only code that I would not like to see is the P607, P06 607, and I don't have that. P6, sorry, let me just rephrase that again. Let me actually go into Identifix because I think I might have saved it. I'm just trying to cover some of the information in here, but I'm pretty sure. Let me go home. So we go on home, and if you click P06, I was saying if we click on P6, sorry, P0607, I think that's the full code. Let me make sure I am in the correct one. Yep. So yeah, P0607, that's a RAM memory fault. So thank you, Brad Davis, to put the information on Identifix. But yeah, as you can see, P0607 is stored in the engine computer, and that is a tapping. And there is a tapping noise from the intake manifold. Check to see the technical service bulletin, and then the technical service bulletin just recommends to replace the PCM. That is an internal um, again, RAM memory fault that cannot be repaired, or at least not with the common and regular uh, procedure. So like it's not a sensor or nothing like that. So as you can see here, let me just see 606 and 607. It says ECM PCM processor. P607 control module performance. So if you have the P0604 internal control module random access memory RAM, so all these fault codes will not be possible to repair the computer uh, on the normal way. Yes, you can send it to me and I will look into it because some are microprocessors that cannot be repaired and some are going to be RAM memory that I might be able to repair. But we don't have that fault code on this computer, and this is what I wanted to show. Like if I read here on the full codes, remember we are in OBD2, we have not a P06, so nothing that worries me in there. So that is good. And then we can get out of here and we can establish the normal communication, not OBD, not OBD. So because that's OBD port, this is now Toyota original software, and we're going to do this is the same thing as in the beginning of the video, that we'll see that, yeah, immediately here, we can read the data stream, and this is where we were reading the coolant temperature sensor. I just want to revisit that, and then we're going to go and read fault codes. Again, this is for United Mechanics in Virginia. So let's go over to the coolant temperature sensor. If I find it, maybe I have passed it or not. We'll see. Find it very quickly the first time. I think it's in the first ones. Maybe it's not. Coolant temperature, yes it is. And we had 152 degrees, so I'm going to change that temperature. And now we got 93, so the computer is reading perfect. The scanner can read the information from the computer. So let's go over to full codes. And remember, an OBD port side or an OBD port area, you're only going to be reading at emission controls uh, codes. Most of the computer ones are going to have to be there because it's very related to. I'm looking for any P6 or nothing like that. We don't have that. It says no communication with the immobilizer. That was not in the OBD area because it's not emissions related. But this it is. So most likely the problem they have it might be in the immobilizer, maybe a key relearn or the actual antenna, the coil, right, where the key is reading that is not reading properly, but that's something I cannot check. All right, guys, so I hope that you like the content that I'm trying to share. I can show you the test you can do here too. So the next thing only that I want to do is let me check that mill. I'll be right back. Let me pause the video 1 second. All right, guys, so I put another terminal onto E6 pin 18 and it's for the mill and it's actually power side control. So the computer is actually sending power. So I connected that to a test line into a ground. So let me just disconnect that so you can see that that light will go off. All I'm doing is disconnecting this E618, which is the mill, and then plug it back in. All right, so see if we, let's try to clear the fault codes and see if the light goes off, because it might not, because, the faults are just steady. So yeah, it will be very hard for me to reset that light. Let me see, are you sure you want to clear the full memory? Clearing the full memory, and it does not, because the faults are returned immediately, and this is something, if I read the fault codes, we're most likely going to have all the fault codes again, because obvious reasons it's not connected. But yeah, so we cannot reset the light because it is there. Let me just turn the ignition off, and we can see the check engine light goes off. Again, this is battery power and this is ignition, so the check engine light is coming on as soon as I turn the computer on, and that is normal operation. So again, nothing wrong with this computer. This is for United Mechanic in Fredericksburg, Virginia. Your computer is working 100%. I cannot reproduce your concern in here. Hi guys, thank you so much for visiting the channel. Don't forget to subscribe, and I hope that you understand and see all the tests that I do here. I am connecting terminals in here because that's easy for me. If you are doing this test on the car, you can do back probing or piercing. Just use a piercing probe and you can check your fiber reference and sensor ground. You can check your powers again with the meter and a piercing probe in these powers into the grounds, and you can check that the grounds are working, the powers are working, and what the communications lines are doing. I hope that this is good for any technician that is trying to check a computer like this and it has no communication, and also to help United Mechanics to do the test in the vehicle and then see if they can narrow down the problem that they have in the vehicle. All right, guys, don't forget to subscribe. See you next time. And again, like Costa Ricans, we said, pura vida. See you next time. Bye bye.